Hi there. Let's deal with the next topic in this unit, and that is looking at the different types of rocks. By now we should be able to be familiar with the different types of minerals and how we use different properties to help identify those minerals, especially density and hardness. Density is one of the most exact properties we can use to pinpoint what kind of mineral we have. So this time around now we're looking at igneous, sedimentary, and metamorphic rocks, as well as how the rock cycle works. So there are three main types of rocks, and they all depend on how they're formed. Igneous rocks are formed from liquid molten rock that cools, and there are two types of igneous: intrusive and extrusive. Sedimentary rocks form from the cementing of small, tiny, broken down bits and pieces of minerals and rock called sediments, and metamorphic rock are rock that change by the effect of heat and pressure. So igneous literally means born of fire, and as I indicated a few minutes ago, it depends on how they're cooled. So this is called obsidian. It's a type of igneous rock, and it cooled very rapidly, and it has almost no crystals. It cools rapidly on the surface of the earth, and so it's extrusive. Extrusive because it formed on the exterior. Most extrusive igneous rocks have small, tiny crystals or no crystals at all, and that's because they've cooled rapidly. So rapid cooling. This is granite. It's intrusive igneous rock, and it forms below the surface of the earth, and it has larger crystals, and it cools slowly. And so you can see here, this little diagram talks about fast cooling, and these are extrusive. Medium cooling would have medium crystal, and slow cooling would have large crystals. Intrusive for these two because intrusive means in the interior. This is showing how the Earth's mantle can come up through the crust, especially during certain points. And so if it comes out like on a volcano, you can get extrusive rock. So rocks are formed by the cooling of magma, which comes from our mantle. Magma cools, it solidifies, and that's how we get igneous rock. Here's granite, which I talked about before. You notice the large crystals. Pumice, this is an extrusive igneous rock. It has holes in it, and it's very airy. This rock usually will float. And the reason it floats is because when it forms on the surface, gas causes huge holes to occur in the rock. So pumice is extrusive, and it's one of the rare floating rocks. I talked about obsidian before. It has very few crystals, or they're really tiny, and it looks like volcanic glass. Here's granite. Granite's often used to make buildings and monuments. Basalt, formed where lava erupted onto the surface. It's one of the most widespread igneous rocks. It's extrusive. It looks like these are big crystals, but they're not. That's just formed from the gas bubbles it formed on the volcano. Here's pumice, many air spaces. Let's talk about sedimentary rock now. Sedimentary are rocks formed when particles of sediment build up and then they're cemented by the effect of pressure. So what happens, thanks to runoff, rocks are broken down by weathering, and they're brought by water down to the sea. And at the edge of the seabed, the sediment is dropped into layers. You can see this picture. The sediment, thanks to the action of runoff, will dump rock, broken down rock, from weathering and erosion into layers. And the bottom layers start to really get cemented due to the weight and therefore the pressure of all the layers above it. And that's how we form this type of rock. So fragments are washed to the sea and they're brought down. You can see in many types of sedimentary rock, you can actually see the layers in them like this one. One way we know it's sedimentary, usually many sedimentary rock have the ending stone in them. So sandstone is formed from the buildup of sand into layers. Conglomerate is a mix of all sorts of different rocks cemented together, and usually they're bigger chunks, like you can see the bigger piece here. Shale. The only place we'll find fossils is in sedimentary rock because sedimentary rock involves no heat and therefore it won't melt and burn away the fossil. So if you ever find a fossil, chances are it's because it was formed inside sedimentary rock. Limestone is a sedimentary rock, sandstone, redstone. Let's talk about metamorphic. Metamorphic rocks are formed by the effect of heat and pressure. So igneous, just heat, but metamorphic, heat and pressure. This can greatly affect the hardness, the texture, or the layers of the rock. So let's say we have a magma chamber down here. Metamorphic rock will form here, and the pressure of the layers above will create this metamorphic rock. So two things, heat below, layers above, will form this layer, which may have been, at one time, this may have been sedimentary rock. And due to the pressure from above and the fact that the sedimentary rock layer is close to a magma chamber, it can convert this sedimentary rock into metamorphic. So metamorph actually means changing form, and we usually will see deformation due to pressure. And other types of rock, for example, sedimentary and igneous, if given the right conditions of heat and temperature, will form into what we call the child rock. So shale, if the right pressure and heat is exposed to shale, it'll turn into a new rock called slate, which is metamorphic. Limestone, which is sedimentary, might turn into marble, which is now metamorphic. The child rock, which is the metamorphic, is always harder than its parent because of the pressure being involved. Granite will form gneiss, so granite is igneous with the right amount of heat and temperature and pressure, granite can form gneiss, and quartz can form the metamorphic rock quartzite. So here's coal, quartzite, slate, which came from shale. So let's put everything all together now. The rock cycle describes the following. In any given set of lifespan, a rock may change from one form to another depending on what's happening to it. Metamorphic rocks could change into igneous rock if they were melted by lava. Igneous rocks with the right heat and pressure could change into metamorphic rocks. And so that's the rock cycle. One more example of the rock cycle. Here's an igneous rock, and it could change into metamorphic. Okay, let's finish up with the rock cycle. This one's a little more complicated, so let's start with basalt. What would have to happen to basalt for it to turn into sedimentary? Well, first the exposed rock would have to get eroded away, and then it would collect at the bottom of a sea, so you get the buildup of layers, and then over time the buildup of layers would cement the sedimentary rock into a sedimentary rock. Let's see what would happen. Let's take sandstone. What would have to happen to sandstone for it to go into an igneous rock? Well, the sediment rock would be buried deep underground, and then once it got exposed to a magma chamber, then the magma would melt it, and then it would cool and slowly cool and reach the surface as intrusive. Let's see what would have to happen to sedimentary for it to turn into a metamorphic. Well, the sedimentary rock would have to get deep inside the earth and then get close to a magma chamber, and at the same time have rocks over top of it. So these rocks would provide pressure, the magma chamber here would provide heat, and now this thing would turn into a metamorphic rock. And what would have to happen to the metamorphic rock for it to turn into igneous? Metamorphic rock lays deep underground, it gets close to this yellow magma chamber, and then eventually it would harden. Or alternatively, a magma chamber could expand, melt, and it could reach the surface as extrusive. So this is kind of intrusive, slowly. This is extrusive. And so that's a quick look at the rock cycle. Here's a label of the rock cycle. Let's have a look at this. Number 1 would be magma. Number 2, crystallization. Number 3 might be igneous rocks. So this is the cooling process. Number 4 might be labeled breakdown of erosion and weathering. Number 5, sedimentation. Number 6, sediments. Number 7, burial deep down, close to a magma chamber, heat and pressure, and now we have a metamorphic rock. And number 9 might be melting again. So there's a quick look at the rock cycle, as well as the 3 kinds of rocks: igneous, sedimentary, and metamorphic.